Hi everyone. So today we will be discussing the January 2021 Mechanics Paper 1. Starting with question number 1. They say a small stone is projected vertically upwards with speed 20 meters per second from a point O, which is 5 meters above horizontal ground. The stone is modeled as a particle moving freely under gravity. Find the speed of the stone at the instant when it is 2 meters above the ground. Okay, how do we find the speed of the stone? So this is the ground. You are projecting this stone at an initial speed of 20 meters per second from a point O, which is 5 meters above the ground. Sorry, so point O is 5 meters above the ground, right? Point O is 5 meters above the ground. Okay, so this is the ground. You are already 5 meters above it, point O. Okay, a small stone is, 20 meters per second from a point O, which is 5 meters above the ground. The stone is modeled as a particle moving freely under gravity. Find the speed of the stone at the instant when it is 2 meters above the ground. So basically, what happens here? You realize that at 20 meters per second, the particle will move up. It will reach at the highest point, the velocity 0, and it will start to come down, right? So they want you to find the speed at the instant when it is 2 meters above the ground. So you have to find the velocity, the speed at this point. What's the equation that you used? What's the equation that you used? P square equals U square plus 2AS. So you can choose your positive direction. I'll choose downwards as positive because V is what I want to find and V is positive downwards. Okay. So I'm trying to find V. Initial velocity is 20 and 20 is upwards. Therefore, it should be minus 20, but we are squaring it. So actually, it doesn't make an effect. And then plus 2 into acceleration due to gravity is 9.8, right? 2g. And it should be what g according to the way that I mark downwards positive. G is going to be negative g, right? Minus 9.8 because we are applying the equation. I'm applying the equation downwards. It should be positive g. Are you with me? I'm applying the equation downwards. So G is positive downwards and displacement. What about the displacement? What did you use for the displacement? Did you use 2 meters? Okay, so the thing is you are measuring your displacement from where? You start measuring everything from this point O, right? You start from point O, not from the ground. So the displacement, everything, the time, we start our time 0 position is at this point O. So displacement will be measured from point O. So from point O until this point where the particle is right now, the displacement is the distance between these two objects, not from the ground. So how much of a displacement do we have? This is 5 meters above the ground. This is 2 meters. The difference is 3 meters. And since I used my equation downwards, you can see from point O to this point, the displacement is 3 meters downwards. You see, therefore, I have a positive 3 here. If there's anyone who used the equation upwards, you will be using the displacement as negative 3. If by chance you use this upwards. Okay? Okay, then what's the answer? V square equals, this is 400 plus 6g. Can I know the value? How much is V? V is the root of this. How much is 400 plus 6g? Give me the answer to 3SF at the end. 400 plus 6 times 9.8. Which is 458.8. And then you have to take the root of it. So square root answer gives me 21.4196. So make sure you give your answer to 3SF, 21.4 meters per second. Okay, make sure answer is given to 3SF. Next part. They say part B, the total time between the instant when the stone is projected from O and the instant when it first strikes the ground. Okay, you have to find the total time between the instant when the stone is projected from O and the instant when it first strikes the ground. Okay, so how do we find the time taken to strike the ground? What equation did you use? Basically, you have to find the time it takes to reach the ground. Yeah, we can go with S equals UT plus half AD square, right? We have to find the time taken. Yeah. S equals UT plus half AD square. So this is from point O until you strike the ground. I will use the equation downwards because I can see from O to the ground, the displacement is downwards. Okay, if you want, you could use upwards. So from point O until you reach the ground, how much of a displacement? How much has the particle displaced? It has displaced 5 meters, right? From point O until it reaches the ground. So it's 5 meters. Initial velocity is 20, but that is upwards. And I'm using the equation downward, thereby it should be minus 20. Time is unknown. Plus half into acceleration is positive 9.8. Do you agree? Because we're moving, I'm using the equation downwards. So G is positive 9.8 into T square. So I end up getting a quadratic equation. Can you see? I end up getting this quadratic equation. Can you see? So if I fix it, I get here 4.9 T square minus 20T minus 5. Is that okay? And then make sure you show how you solve this equation. So to solve this equation, we can use the quadratic formula T equal minus B. Isn't it? You know the equation, right? X equal minus B. This is from P1 plus or minus square root B square minus 4AC divided by 2A. So this is all you need to use. Replace the ABC value. So A is 4.9. B is minus 20, C is minus 5. T equal minus B, so minus 20 plus or minus square root B square minus 20 square minus 4 into A is 4.9 into C is minus 5. Divide by 2 times A is 4.9. Can I have the two T values? Give me the answers. What are the answers? Just need to show it, right? And then you could yeah, we could even go with this. 4.9 minus 20 and minus 5, right? So I get the T values. I get 4.317. Is that okay? So you must just show the working, okay? So I get 4.3179, 4.31795, and the other answer minus 0.23. Okay, so we definitely know that time cannot be negative, right? Okay, so then the correct answer, we'll give it to 3SF. The correct answer is T equals 4.32 seconds. Okay, so you can see here, I typed this in the calculator, but I wrote the method here. Okay, so you could type this in the calculator as well and get the answer, no issues. But make sure you show your methods. Okay, but this is not the only way to get 4.32. So some of you might do this in a different way. There are many other ways of doing this same sum. What are the other ways? For example, you could find the time taken there to go from a point O to this displacement 3 meter point. Because you already have the final velocity, you could find that time and then find the time taken to go for the remaining 2 meters and add the 2 times. So there are many other ways to get this answer as well. Okay. End of the day, all answers must be equal to 4.32 seconds. Correct to 3 significant figures. Question number 2. Two particles P and Q have masses 2m and m respectively. The particles are moving towards each other in opposite directions. So you have the two particles P and Q have masses 2m and m. The particles are moving towards each other in opposite directions along the same straight line on a smooth horizontal plane. So they are moving towards each other. The particles collide directly. Immediately before the collision, the speed of P is 3u and the speed of Q is 2u. The magnitude of the impulse exerted on Q by P in the collision is 5 mu. So basically they say the impulse on Q by P, but you know, this impulse is an equal and opposite force, right? Impulse is not just going to act on P and not only it's going to act on Q as well. Both particles will experience the exact same impulse equally in the opposite directions. So P feels, but when P and Q collide, P will feel the impulse backwards, right? and Q feels the impulse in this direction. So these are the two directions that the two objects will feel the impulse. So Q feels the impulse 5 mu to the right direction. P feels the impulse 5 mu to the left direction. Do you agree? And they say find the speed of P immediately after the collision. So okay, we have to find the speed of P immediately after the collision. Okay, so what you could do is you could kind of like maybe assume the equation here 3u into 6m, that's 6mu. Here 2u into m, that's 2mu. So you can see this side is having a higher momentum, right? So I will choose to write this as the positive direction. So let's say this is speed x and this is speed y. Okay, so I'm supposed to find the speed of P immediately after the collision. I have to find x. So what's the best thing to do here? What equation am I supposed to use? For P, we will use what? I equals impulse equals change in momentum, mv minus mu. This is the easiest equation to go with. So impulse I will use because P is having the impulse backwards. I will choose the backward direction as positive. Are you with me? Okay, then impulse is 5 mu. Mass is 2m, right? Mass is 2m. Final velocity x. So I have marked x positive in this direction. I'll have to change it. That means I'll have to make it negative. Minus mass is 2m into initial is 3u. So that is also to the right side. So we need to change these 5mu. So this when I change direction, it becomes minus 2mx because I'm changing. So it becomes plus 6mu because I'm changing the direction. The m will cancel out. And I get here 5u equals minus 2x plus 6u. Are you with me? So I get here 2x equals 6u minus 5u. And I get that's 1u, x equals half u. The speed of P immediately after the collision is half u. So x is half u. Positive answer means the direction that I used is correct because I was kind of like speculating the direction here. So that direction is definitely correct, half u. Is that clear? And part B, get the speed of Q after the collision. Again, what do we do? To get the speed of Q, we use for Q, I equals mv minus mu. Are you with me? So I equals mv minus mu. So for Q, what's the positive direction? For Q, the impulse is acting, the right side is the positive direction. Then we apply 5 mu for Q, impulse. Mass of the object Q is m, right? Final velocity is y. So all of them are to the right. Minus mass is m. Initial velocity 2u to the left. 2u, but that is to the left. So we need to convert that direction because in the impulse the equation should entirely be in one direction. So it's gonna be 5 mu equals my. This is gonna be plus 2 mu, right? And then you can cancel out the m. And you get here 5u minus 2u, 3u equals to y. Can you see the speed of Q is 3u. So this is the speed of Q after the collision. Is that clear? So we've got the answers for A and B. Okay, moving on to question number 3. A parcel of mass 20 kilogram is at rest on a rough horizontal floor. The coefficient of friction between the parcel and the floor is 0.3. Two forces both acting in the same vertical plane of magnitudes 200 Newton and 3 Newtons are applied to the particle. The line of action of the 200 Newton force makes an angle of 15 degrees with the horizontal, and the line of action of 3 Newton force makes an angle of 25 degrees with the horizontal as shown in figure 1. The parcel is modeled as a particle P. Find the smallest value of T for which P remains in equilibrium. Okay, the smallest value of T. So now in here you need to realize there are a few things you need to realize. Now here they say the critical word here is what? The smallest value, right? What's the smallest value of T so that this remains in equilibrium? In another question, they could ask you what's the largest value of T for which this particle is in equilibrium. These are questions that they ask. Now, when they say it's the smallest value of T, what do you need to realize? Now here, you know, it's a rough flow, right? So if it's a rough flow, you have friction. So basically the smallest value of T and the largest value of T, the difference in the two words is those two words make an impact for the direction of your friction. The direction of the friction is impacted by using the word smallest or greatest. So how do you think it's affecting? If you want the smallest T value here, how do you think the friction is going? So if this value is as small as possible, the smallest value we could use here so that the object remains in equilibrium. So it means that friction will be coming to which side? Are you going to use friction to the left side or to the right side? You're going to use it to the right side. How do you say that? Because we need this to be as small as possible. This small value plus the friction should be able to balance out this 200 over here. Okay, we need to resolve. We'll have to resolve it. But basically, if this is small, we'll need some support over in this end to balance out with this end. Do you understand? However, if they say that T is the greatest value, what's the biggest value we could get for T? What happens? If this is really large, then we need to apply friction to the other way. In that case, both of them together is balancing out the T, which means that T becomes as large as possible. Understood? So that is where the value of the smallest and greatest plays its part. And this is something they definitely test in the exam. So here the smallest value means you realize your friction is acting in this side. Yes, friction will act on the same side as tension. The mu r friction. We will apply the limiting equilibrium friction because we want the maximum friction. Because when you're having the maximum friction, it means the object is about to move. Okay. Shall we resolve the remaining components? So what happens when you resolve? So when you resolve to this side, you get mu r plus the T cos 25. Do you agree? The tension resolves T cos 25. Upwards, your tension resolves T sine 25. And then your 200 Newton resolves over here in this end. So this becomes 200 cos 15 because we need to have the vertical horizontal. And the vertical will be 200 sine 15. Are you with me? 200 cos 15, 200 sine 15. Okay. So now all we need to do is make the equations, right? So we have to balance it out. The parcel, the weight is 20 kilograms. So 20 kilogram means weight is 20 G. And what else do we have here? Are all the forces done here? No, we have to mark one more person. Who is it? Normal reaction. Normal reaction should be upwards, right? Shall I, normal reaction is acting upward. Shall I just put plus R? Because the normal reaction is also acting upwards over here. So normal reaction plus the T sine 25 plus the 200 sine 15, isn't it? So now we just have to make our forces balance. So let's write the equation for horizontal equilibrium and vertical equilibrium. So R plus T sine 25 plus 200 sine 15 equals to what? Equals to the weight 20 G. Here you see, so it's actually a pair of simultaneous equations here. And then the second equation, this is considering vertical equilibrium. So if you consider left equal right, what do we get? Mu r plus T cos 25 equals to 200 cos 15. Are you with me? Okay, so mu value was given to us, right? Mu was 0.3. 0.3 r plus T cos 25 equals 200 cos 15. Okay, so now it's a matter of solving these two equations simultaneously. What I'll do is, shall I make R the subject from the first equation, input that over here, and then we can make T the subject. There are many ways of doing, so it's you can choose any correct method. So I'll make T the R the subject from the first equation, 20G minus T sine 25 minus 200 sine 15. Okay, and then input that R value here, 0.3 times. R is 20G minus T sine 25 minus 200 sine 15 plus T cos 25 equals 200 cos 15. 0.3 into 20, can I know how much is it? Now, another thing is this, okay? So I think most of you might have a habit of, writing the sine 25 values, sine 15, cos 25 values. Do not type them in the calculator. We will go for those calculations at the very end. At this point, let's just multiply. 0.3 into 20 is giving us a whole answer, which is 0.3 into 20 is 6G. So I get here 6G minus 0.3 T sine 25. You can see I'm not getting the decimal values here. 0.3 into 200. 0.3 into 200, 60 sine 15 plus T cos 25 equals to 200 cos 15. So what will I do in my next step? I will keep the T terms over here and take everyone else to the other side. So minus 0.3 T sine 25 plus T cos 25 stays here, while 200 cos 15 minus 6G is going, plus 6G goes as minus 60 sine 15 goes as plus 60 sine 15, right? Plus 60 sine 15. So, yeah. They write everyone down. 200 cos 15 is here, plus minus 6G plus 60 sine 15, right? Yeah. So they came over here, signs change. Now take T out. Can you see what's going on? And then when we come to this step, the very last step is where I type everything in the calculator. Tension equals 200 cos 15 minus 6G plus 60 sine 15 divided by minus 0.3 sine 25 plus cos 25, right? Is that okay? So type this in the calculator. 200 cos 15, and calculator must be in what mode? Degree mode, right? So my calculator was in radian mode, should be in degree mode. On top it should be D. So 200 cos 15 minus 6G is 9.8 plus 60 times sine 15 divided by minus 0.3 times sine 25 plus cos 25. Is that okay? And I get 192.315. Okay, so definitely we should keep our answers to what? You must keep your answer to 3SF. Okay, 3SF or 2SF is also okay. Okay, you can leave your answers to 3SF or 2SF. Okay, whenever you use G as 9.8, you must keep the answer to 3SF, or you could keep it in the equivalent 2SF. So tension is 192 point. You could write the whole thing first, 192.3156, and then make sure you give the 3SF answer or 2SF, 192 newtons. Okay, is this clear? Okay, moving on to question number 4. A metal girder AB has weight W Newton and length 6 meters. Okay. The girder rests in a horizontal position on two supports C and D, where AC and DB are both equal to 1 meter. Can you see? And shown in figure 2. When a force of magnitude 900 Newton is applied vertically upwards to the girder at A, okay, when a force of magnitude 9000 Newton is applied vertically upwards to the girder at A, the girder is about to tilt about D. Okay, so when you apply a force here, it's going to tilt about D. When a force of magnitude 1500 Newton is applied vertically upwards to the girder at B over here, it's about to tilt about C. Okay, so we have two scenarios. We have two situations here, right? So the girder is modeled as a non-uniform rod. Non-uniform rod means the weight doesn't act at the center. Okay, whose center of mass is a distance x meters from A. Find the value of x. Okay, so you have two situations here. You have to make up a pair of simultaneous equations for each situation. You have to make up an equation and you have to solve the equations together to get it done. Okay, so what we'll do is first we'll have to draw two sets of diagrams. Okay, so draw this diagram. We have to draw two sets of diagrams and solve a pair of. Okay, so first I'll draw the first. We'll draw the first force diagram. That's the first one. The first thing is when you have supports at C and D, you realize that you have normal reactions at C and at D, right? Okay, when there are supports, you have normal reactions. Okay, however, okay, I think one of these normal reactions we'll just write here normal reaction C and normal reaction D. So what happens, they say when a force of magnitude 900 Newton is applied vertically upwards to the girder at A. So you are applying a force of 900 Newton vertically upwards to the girder at A. The girder is about to tilt about D. The girder is about to tilt around D. So when you're tilting around D, what happens when you're tilting around D? Now you give this force upwards. Basically, it's trying to move up, right? It's trying to move up around the point D. So whenever this tilting word comes into play, do you remember a certain rule? Do you remember? Because it's trying to move up, the normal reaction there. So one normal reaction in this from these supports will be removed. Basically, the normal reaction at C will become what? 0, because you will kind of like lose the contact at this point, because it's about to move up, you will lose the contact here. Okay, so that is the most important thing. And then I have to mark the weight. I have to mark the weight. Weight is W newtons, right? Weight is W newtons, and the distance from A is X. Okay, so weight, I have to mark it as W newtons. So it's non-uniform, okay? Weight W newtons at a distance of X meters. At a distance of X meters from A. Okay, so what we'll do here is whenever they use this word, it's about to tilt around a certain point. What should you do? You must consider moments around the tilting point. Are you with me? You must consider moments around the tilting point, because the entire weight of the whole system comes at the point D when it's tilting. So do we need to use up equals down and do anything like that? We don't need to. The only thing you have to do here is just do one thing. Take moments around D. That's all, because it's about to tilt. So you take moments around D for this situation. Take moments around D, choosing one direction, either clockwise or anti-clockwise as positive, and apply the equation. So what happens? The only force we have, there are only two forces to be considered here, right? The 900 Newton and the weight. Normal reaction at C is not necessary, isn't it? Normal reaction at D will not come into the story because you're taking moments around D. So any force that goes through point D will not produce a moment. So let's take moments around D. What happens? 900 Newton into how much of a distance do we have? From 900 Newton to point D, how much of a distance do we have? 5 meters. Why? Because the whole thing 6 meters, D to B 1 meter, which implies A to D must be 5 meters. And is it a clockwise moment or anti-clockwise moment when 900 meter is pulling this upwards? So it's pulling it upwards around D, so which means you can see it's a clockwise moment. So I'll name it plus. And then what about the moment given by W? So W around D, you can see W around D, W is pulling in this manner, right? Because it's pulling around D. So it's an anti-clockwise moment. Do you agree? W produces anti-clockwise moment minus W into what's the distance? What is the perpendicular distance between W to D? Yeah, so you know this whole distance was 5, right? Because this is 6 meters, we just found out. This is 1 meter, 5 minus 1. This is 5 minus, 6 minus 1, it's 5 meters here. So from that 5 meters, when you remove the x, you get this small distance as what? 5 minus x. Do you agree with me? This whole thing is 5. The whole thing is 5. From there, when you remove x, the small part is 5 minus x. So W into 5 minus x. Are you okay with that? So this is equal to what? This is it, right? These are the only two forces that produces moments. So these two moments must be it's equal to 0 because it's in equilibrium. It's about to tilt, but it's still in like equilibrium. And then this is one equation. So it's like you have equation with two unknowns, W and X. So now consider the other scenario, the other part, and mark forces here and make another equation. So we'll go to the other one, mark the forces again. When a force of magnitude 1500 Newton is applied vertically upwards to the girder at B. Okay, so now you go to B. Okay, now you go to B and give a 1500 Newton force upwards. Okay, and then you still have the weight at the unknown position here, W. And again, you still have your two normal reactions, but the normal reaction values might not be the same as the earlier ones. Okay. But what do they say now? Okay, they might be totally different in values because of the forces, but they say now when you apply a force of 1500 Newton is applied vertical to the girder at B, the girder is about to tilt about C. So now what's happening? When you give this 1500 force upwards, it's now going to tilt around C. Are you with me? So when it's about to tilt around C, what happens over here? So this is lifting, right, at this corner. That's why it's going to tilt around. See, if it's lifting at this corner, what happens? It's almost about to lift. The support at D, it loses the contact. Thereby, the normal reaction at the point D will be 0. So you do not have a normal reaction there. The entire weight of the whole plank falls on C. Okay. So when you have about C, what should we do? Definitely take moments around C, because that's the place where you are tilting. So take moments around C. I'll take clockwise as positive. What happens? So what happens? This distance was marked as x meters, right? This was marked x meters. And what else did we have? Okay, we are supposed to take moments around C. So we'll start with 1500. 1500 newtons into how much of a distance do we have from C to the point B? Because from C to B, 1500 is applied at B, and I have to find the perpendicular distance to C. C to B, what's the distance? How much? 5, right? Because this is 6 meters, this is 1. You subtract this 1 and you get the remaining distance from C to B is 5 meters. So 1500 into 5, agree? Minus, is it minus? Wait, I did not check the directions. What's the direction here? 1500 is providing a clockwise moment or anti-clockwise moment around C. It's giving an anti-clockwise moment around C, right? Do you agree? Which means, according to this, it's negative. And then plus the W is giving a clockwise moment. Is that correct? W gives a clockwise moment around C. That's why it's plus. W into how much is the perpendicular distance from W to C? What's the perpendicular distance from W to C? This whole distance is X. What's this distance? C to the point W. It's going to be X minus 1, right? Because this full distance is X and this is 1 meter. So X minus 1. So W into X minus 1 gives a clockwise moment. So all of this equals to 0. Can you see just two equations? Two equations. Solve them simultaneously. Get the value of what? X. Solve the equations and make X the subject. So W into X minus 1 equals minus 1500 into 5. I'll bring it to the other side. How much is 1500 into 5? 7500. In the other equation, I get here 900 into 5 is 4500 equals W times 5 minus X, right? Can you see? So the two equations, if I write them together, the other equation is W times 5 minus X equals 4500. So I think one of the easiest techniques of solving this is what I don't need W also, right? What would be the easiest? You could make 1% the subject and substitute. Okay, there are many ways of solving. So one of the easiest ways here is to divide. Because if we divide 1 divide by 2, we get W times X minus 1 divided by W times 5 minus X equals 7500 divided by 4500. This is not the only way, by the way. You can do this in any way, any technique, substitution. All of them are correct. So I'm just using the easiest way. W to W cancels and 7500 over 4500. Can I have the simplest form answer? What is the simplest form answer? X minus 1 over 5 minus X. How much? 5 over 3. Yeah, 15 times 5, 15 times 3. And then cross multiply with 3 and so 3 times X minus 1. 5 times 5 minus X. So you get 3X minus 3. 5 times 5, 25 minus 5X. Which gives me 3X plus 5X is 8X. 25 plus 3 is how much? 28, right? How much is the answer? Can I know the value here? X equals 28 divided by 8, which is how much? Exactly. How much? 7/2. Or in other words, the exact figure, right? 3.5 meters. Is that clear? This is what you have to do for the 6 marks. Draw 2 diagrams, take each one separately, make the 2 equations and solve it simultaneously. Okay? Okay, question number 5. A particle is acted upon by two forces F and G. The force F has magnitude 8 Newton and acts in a direction with a bearing of 240 degrees. The force G has magnitude 10 Newton and acts due south. Given R equal F plus G, find the magnitude of R. Okay, so there are different techniques of doing this sum. So one technique would be that you draw the diagram and actually use the triangle, right? You can draw the triangle here and the yeah. So that is one method. Actually, I prefer to go in a little bit of a different technique here. Okay, what I will do here is I will convert all these forces in terms of ing. Just have a look at this because it will be easier for certain types of sum. Like if you have f minus g or 2f plus g, so they could give you different sorts of things here. So if you could convert your forces f and g in terms of I and j, it makes it a lot easier to do any complex kind of sum. Okay, so this is a basic one. Even the triangle method will work by using the cosine rule. Okay, so anyway, I will go in this method. Now they say the force F has magnitude 8 newtons and acts in a direction with a bearing of 240. Let's first mark force F. So this is the north. It's acting at an angle of 240 degrees. That means it's somewhere over here, right? It's somewhere over here. And the magnitude of the force is 8 newtons. Are you with me? So can I know the angle here? If this is 240, you know, this is 3/4 means it's 270. How much of an angle do we have remaining over here? 240, 50, 60, 30 degrees, right? Then it becomes 270. So now you could take the components of the force. Take the components of the force. What happens? You get here 8 cos 30 towards the angle and the other one is 8 sine 30 away from the angle. Do you agree with me? So I could write my force F as, what is it? 8 cos 30 is the horizontal force and it's to the left side, which means it's going to be minus 8 cos 30 I. Because you know, when you do IJ, positive I means when you are going to the positive side of the x-axis. Negative I is if you go to the left side of the x-axis. Positive J is if you go up, negative J if you go down. Are you aware of this? Okay, so positive I is 1 unit along the x, negative I is 1 unit along the negative x-axis. So here I'm going 8 cos 30 units backwards, thereby I get minus 8 cos 30 I units. And then what about the 8 sine 30? Is it positive j or negative? It's negative 8 sine 30 j because you're going downwards. Can you see? So I managed to convert this the force entirely in terms of I and j. Okay. So now my force is entirely in terms of I and j. Let's write g also in a similar manner. So they say the force G has magnitude 10 newtons and acts due south. So from here, north, you act due south means you are going directly down. 10 newtons directly down. So what's the force G? 0I minus 10J. You don't need the 0I. You could just say directly it's minus 10J because it's acting 10 newtons downwards. Do you agree with me? This is the easiest way. So there's nothing to resolve here because the force is directly acting vertically downwards. If your forces are vertically downwards or horizontal, we don't need to resolve. Only forces that are that have an angle to the x-axis, y-axis should be resolved. Okay, so this is it. Now you can easily find F plus G. So F plus G, just add it, right? You know, when your forces are in terms of I and J, to get the resultant, you just need to add the forces. That's the advantage of having your forces in terms of I and J. Simply add the forces and you get the resultant. Minus 8 sine 30 J. I have to add F with G. Minus 10 J. Shall we add? Minus 8 cos 30. How much is minus 8 cos 30? Multiply minus 8 cos 30. Calculator must be in degree mode. What do you get? Minus root minus 4 root 3I. This is 8 into sine 30 is 8 into half, so minus 4j minus 10j plus into minus. End of the day, I get minus 4 root 3i minus 14j. Okay, so this is the value of r. And then how do I get the magnitude of r? Minus 4 root 3 u squared minus 14 u squared, and then you take the root. How much is it? How much is it? So I get here inside the root for the magnitude, I get root 244, which when you simplify, it gives 2 root 61, right? And they want the magnitude of r. Yeah, so you could give it to 3SF. How much is it? 2 root 61 is 15.6 newtons, correct, 3SF. This is the magnitude of r. Do you agree? Okay, then the next part, Roman number 2, the direction of r, giving your answer as a bearing to the nearest degree. So isn't it a lot easier to give the bearing of r now, because we know r is minus 4 root 3i minus 14j, which we found in the earlier part. So all you have to do is to mark it on a diagram. So you draw your x-axis, you draw your y-axis, and minus 4 root 3i minus 14j. Can you see? So it should be over here, right? Can you see how do you get the bearing? Bearing is measured from the north to the clockwise direction. Bearing is measured from the north to the clockwise direction. So you just need to get this, isn't it? Do you agree with me? So one method of doing is you could get the theta value over here and add it to 180 to get the bearing. Another method is you could mark theta over here and subtract it from 270. So which one? Any method is okay. I'll go with this one. I'll find theta here and add it to 180. Any method is okay. Tan theta opposite over adjacent. Opposite is the x distance, 4 root 3 over adjacent is 14. Okay. So can you all get tan inverse? Tan inverse 4 root 3 over 14. How much is it? 26.3. Tell me the answer for tan inverse 4 root 3 over 14 is 26.3295. Okay, then let's get the bearing. So bearing is you have to add the 180 and the theta. So 180 plus 26.3295. How much is it? How much? 206.3295. So bearing 3 figures. So 206 degrees. This is the bearing. Okay, is this clear? So this is the easiest way to get the answer. Okay, so now we'll move on to question number 6. Two girls, A and B, I'll say A and B, okay, are roller skating inside a largely empty building. The girls are modeled as particles. At time 0, A is at the point with question vector 11i plus 11j, and B is at the point with question vector 7i plus 16j. Now we know this is the vector question. Just one look at it and you know this is the vector question, right? So we'll write, we'll model each person here, A and B. The R naught for A is because when you say time 0, you know you're talking about the initial question vector, the starting question vector. For A, R naught is 11i plus 11j, and for B, R naught is 7i plus 16j. The question vectors are given relative to the dou O. Okay, so the dou is the 0, 0 point, and I and j are horizontal perpendicular unit vectors. A skates with constant velocity 3i minus j meters per second, and B skates with constant velocity 4i minus 2j meter per second. Find the position vector of A at time t seconds. How do you find the position vector of A at time t? Time t seconds, what equation do we use? R equals R naught plus Vt. This is the equation that is only to be used when the object is moving at constant velocity. So this gives you the position vector, the coordinate, how the end starting coordinate, and R is the ending coordinate after t seconds. So you're supposed to get the coordinate in terms of t, right? So because at time t seconds, R naught is 11i plus 11j, velocity is 3i minus j, into time is t. So R is 11i plus 11j plus 3ti minus tj. So R equals 11 plus 3ti plus 11 minus t times j. Is this okay? Is this okay? Did you get this answer? So I separate. You could leave your answer at this point, okay? But I just went a step further to separate the x and y, I and j, okay? At time equals 6 seconds, A passes through the point P. Show that B also passes through P and find the value of T when this occurs. Okay. So at time 6 seconds, A passes through the point P. Let's first get the position vector at time 6 seconds. You can find the position vector of A, right? So get the position of A when T is 6. What do we get here? R equals 11 plus 3 times 6i plus 11 minus 6j. How much do we get for R? 11 plus 3 times 6. How much is it? 29i, and 11 minus 6 is 5j. This is the position vector of A. Okay, and then what they want you to do is they say B is also passing through this point P. But it's at a different time. They are asking you to find the value of T when B passes through this point. Do you get what's happening? Okay, A passes through this point at time 6 seconds. They say B will also pass through this point, but they haven't given you a time. So you have to find the time when does B pass through this point. So how do we find that? We go for B, we apply what? R equals R naught plus Vt. And what's happening? The final position vector is now 29i plus 5j. The R naught is the beginning, which is 7i plus 16j. Are you with me? The R naught is the beginning, 7i plus 16j. And then plus velocity. Velocity is known, right? Velocity is how much? 4i minus 2j. Into time is t. Do you agree? You are supposed to find the t value. Shall we make the, find the value? So here we get 29i minus 7i is how much? 29i minus 7i is 22i. 5j minus 16j, can you subtract? 5j minus 16j minus 11j equals 40i minus 2tj. So what you could do here is after you come to this point, separate, compare coefficients for I and j separately. So compare coefficients for I and j separately. So when you compare for I, we get 22i equals 40, right? I get t equals 11 over 2 seconds. So check whether you get the same t when you compare coefficients for j, because end of the day, when you do, because we can't make t the subject here when you are t, because t is a constant here. Take the I component, take the j component, and both the components must give the exact same t value. If it is to pass through this point. If you're passing through this point, then the t values must be the same when you compare I and compare j. If you get two different t values, it means the particle won't pass through this point. Okay. Compare for j also, minus 11j equal minus 2tj. So you can clearly see t equals minus 11 divided by minus 2. Which is again 11 over 2. Or both of them are 5.5. Agreed? Next, we'll move on to part C. They say at time t seconds, A is at the point A and B is at the point B. Show that AB vector is equal to this. Okay, how do we get the AB vector? Now you do realize you found the position vector of A at time t seconds, right? So basically the position vector means what? A position vector means it gives the coordinate at any given time. So basically in part A, at any given time, you can input the time and you know exactly where A is. You can see the I gives the X coordinate, the J gives the Y coordinate. Put any time, substitute any time, and you know exactly where this person is because it's moving with constant velocity. So you at any given time, you know where this person is going to be. Okay. So this is basically, in other words, we say this is OA. Why do we say OA? OA means this is the position of A relative to O because these coordinates are measured with respect to the origin, isn't it? So likewise, you need to do for B as well. Okay, so when we do for B, you will apply R equals R naught plus VT. R is what we are trying to find. R naught of B was how much? 7i 7i plus 16j, right? Over here, I have written R naught is 7i plus 16j plus the velocity is 4i minus 2j into time t. So when you separate R equals 7i, I could do it at once. I'm writing an extra step, but this is an unnecessary step. You could go to the answer directly where you separate I and j. You can go to it. So 7i plus 40i, 7 plus 40 times I. This is 16 minus 2t times j. Are you with me? So then we get here, this is the R, which is what? This is the position of B, OB, the position of the ship B with respect to the origin. Because this gives you the X coordinate and the Y coordinate measured from the origin. Do you agree? And now what are we supposed to find? We are supposed to find AB. How are we going to find AB? AB is B minus A, isn't it? Or we say AO plus OB. Or in other words, OB, when you make it to OA, it's minus OA. Okay, so you are aware of this, right? This is vectors. So OB we already have over here. 7 plus 40i, 16 minus 2tj, and then subtract with OA is, we have OA, right? Already we got the position vector of A with respect to T. That was 11 plus 3ti plus 11 minus tj. So how much is the AB vector? So when we open, you could reduce a certain amount of steps. I'm writing extra steps. Again, I'm saying that it's not necessary to write this step. Okay, just for your understanding, minus 11 plus 3t whole thing I, because I'm opening the bracket with the negative sign. Okay, only the outside. Okay, I'm not taking the minus inside the 11 plus 3, but just keeping it outside here. Minus 11 plus 3ti, minus into plus, it's minus 11 minus 3 inside bracket. J, can you see? And then I take the I terms together. And then I take the I terms together. And then I take the J terms together. Seven plus 4ti minus 11 plus 3ti. Can you see? This is all with I. I took it outside a large bracket. Can you see? 7 plus 40i and minus 11 plus 3t. Can you see? For j also. 16 minus 2tj minus 11 minus tj. So when we simplify, what do we get here? 7 minus 11. Can you all get me the simplified version here? Open 7 plus 40 minus 11 minus 3t. How much is it? 7 minus 11 is minus 4 plus 40 minus 3t is plus 1t. Agreed? The other one? 16 minus 2t minus 11 plus t, isn't it? Because this is minus minus plus. So minus 11 plus t. 16 minus 11 is 5, minus 2t plus t is minus t. Do you agree with me? So this is minus 4 plus ti, 5 minus tj, which is the show that, right? Minus 4 plus t or t minus 4i, 5 minus tj meters. So I got the show that. Can you see? T minus 4 is the same as minus 4 plus t. Shall we move to the next part? In the next part, they say part D, find the distance between the two girls when they are closest together. Okay, how do we get the distance between A and B when they are closest together? How do we get the distance between them when they are the closest to each other? Gotta get the distance between these two when they are closest to each other. Now you do realize here when you get now there is an advantage of finding the vector AB. What is the advantage of finding vector AB? Now when you were finding OA, the vector OA, it means you measure the coordinate of A with respect to the origin. OB when you found it was the coordinate of B with respect to the origin, right? So OA and OB was when you found it with respect to the origin. But when you find AB, what happens? AB means what? The position of B relative to whom? AB means the position of B relative to A. Isn't it? So basically, AB means the position of B is given with respect to A. So that means in the AB vector, the advantage of using the AB vector is we don't need to deal with the origin anymore. So in AB, you can see the B relative to A, the x distance is minus 4 plus t. So basically, you could make a triangle like this, the x distance and the y distance. The x distance between A and okay, just I'll explain this part again. Okay, so to find the distance between the two girls when they are closest together. Okay, so when they are closest together in part D, I was explaining you now there is an advantage in using the AB vector. Why? Now in AB vector, as I was saying to you previously, okay, now earlier we got the OA vector. OA was when you measure A with respect to the origin. OB vector is when you measure B with respect to the origin, OA, OB. But what's the advantage of taking the AB vector? When you take the AB vector, what happens is it's the position vector of B relative to A. That means A is considered as the initial. So with respect to A, they give the coordinates of B. So in that case, we don't need to consider the origin. Okay, we can directly go from A to B. So basically what happens here is from A, you could draw this triangle, the right angle triangle, and the x distance between A and B is minus 4 plus t. Can you see? The x distance between A and B is minus 4 plus t. And the y distance between A and B is 5 minus t. Are you with me? Okay, the x distance between A and B is minus 4 plus t. The y distance between A and B is 5 minus t. Okay, so now what we can do is, by using these coordinates, by using these two, can't we find directly the distance between A and B at any given time? How do we find the distance? Distance is directly AB distance, right? You have the x distance, you have the y distance. How do we get the distance between A and B? Basically, if you take the magnitude of the AB vector, do you realize you get the distance from A to B? If you take the magnitude of the AB vector, which is minus 4 plus t square, plus 5 minus t square, square root, okay, minus 4 plus t square plus 5 minus t square. If you take the root of it, you get the distance between A and B, the distance D. Okay, so distance D, shall we open this? This is the root of minus 4 plus t square. We'll remove the large root by squaring the distance. So d square is I'm removing the large root by squaring. The large root removed. Shall we multiply inside? Minus 4 into minus 4 is 16. Minus 40 minus 40 into t is t square. The next one, 5 times 5, 25, minus 5t minus 5t minus t into minus t is again t square. Do you agree with me? Taking everything together, I get d square equals, how much is it? Plus t square is 2t square. At the t values, minus 4t, minus 4t, minus 5t, minus 5t. How much is it? Minus 18t. And if you add the constant 16 plus 25, how much is it? How much? 31. 2t square minus 18t plus 31. Okay, so this is the distance equation. Can you see the distance now? Now the distance between the two girls, do you see it's a quadratic graph? The distance square equation between the two girls, A and B are the two particles or the two girls. So you can see the distance square between the two girls follows a quadratic equation, and it's a quadratic what equation? It's a quadratic what? Maximum or minimum? It's a quadratic, it's a plus t square, so thereby it's a quadratic minimum equation. So you need to find the least distance between the two of them, right? So the least distance means you have to find the minimum point. Because at the minimum point, you get the minimum distance. The minimum distance square, actually, you get the minimum distance square. You could root and get the minimum distance. Are you with me? So basically, what you need to do is you have to get the turning point. How do you get the turning point? Let's say the distance square is y. Let's say the distance square is y. Distance square is y is equal to 2t square minus 18t plus 31. Can't you find the minimum point? What should we do to get the minimum point? dy by dt. In here dx, there's no x, there's dt, dy by dt. Because the gradient is 0 at the turning point. It's a quadratic minimum graph. So you get here 4t minus 18 plus 31 is 0. So you make it equal to 0. At the turning point, 4t minus 18 gives you 18 equals 40, which is t equals 18 divided by 4, which is 9/2. So at 4.5 seconds, you reach the minimum distance point. They're asking you to find the distance. So apply d square equals 2t square minus 18t plus 31. Replace the t value with 9/2. 2 into t square is 9/2 square. Minus 18 into t is 9/2 plus 31. How much is it? How much is the distance square value? How much? Yeah, I want the value here. Yeah, so there's a slight error here. 16 plus 25 is not 31, right? Should be 41. Okay, should be 41 here. That's why we get the error at this point. The dy by dt doesn't change because the 41 doesn't come for the differentiation, but it comes here for the distance. Input 41 here. The mistake comes from here, okay? 16 plus 25 is 41. And then we get the distance, d square value is how much? Half. And then get the d value, the root of the distance, root of half, which is how much? Root 2/2. Can I know the decimal figure? 0.707 meters. So this is the closest. This is the shortest distance between the two girls. Okay, is this clear? Okay, moving on to question number 7. A helicopter is hovering at rest above horizontal ground at the point H. A parachutist steps out of the helicopter and immediately falls vertically and freely under gravity from rest for 2.5 seconds. Okay, so he's freely falling for 2.5 seconds. His parachute then opens and causes him to immediately decelerate at a constant rate of 3.9 meter per second square for capital T seconds, where capital T is less than 6, until his speed is reduced to v meters per second. He then moves with this constant speed v meters per second until he hits the ground. While he is decelerating, he falls a distance of 73.75 meters. The total time between the instant when he leaves H and the instant when he hits the ground is 20 seconds. Okay, so that's a lot of information here to process. You know what the best thing is? We will draw a vertical diagram they are depicting each stage of the parachute is fall. So what I'll do here is that this is the helicopter, so and this is the parachutist. So we'll start with the at the very top. So this is the place where he is jumping out. So the initial velocity is 0, isn't it? So what happens? He's falling freely for how many seconds? He steps out of the helicopter and immediately falls vertically and freely under gravity from rest for 2.5 seconds. So for 2.5 seconds, you are falling freely. Are you with me? So this is falling freely. This is for 2.5 seconds. Are you with me? We don't know how much of a distance he fell, but we can find it. And end of the day, let's say after he comes to this point, when the parachute opens, let's say he achieves a speed V1. Do they give a speed here? His parachute then opens and causes him to immediately decelerate. Okay, so let's say he's freely falling and achieves a certain velocity V1, and then at this point the parachute opens. So when the parachute opens, what happens? Now is he going to continue? You need to realize that in the first 2.5 seconds he's falling freely under gravity. Means what acceleration does he have, by the way? He has the 9.8 acceleration, right? So the acceleration here is the 9.8 ms minus 2 acceleration. Okay, in this section. After this section, he achieves the speed V1 and now the parachute opens. So when the parachute opens, now the next part of the journey, how does it go? How does it go? The next part of the journey, they say, his parachute then opens and causes him to immediately decelerate. Decelerate means he's going downwards, but it's a deceleration, which means a negative acceleration. So now his acceleration is minus, how much is it? 3.9. Why did I put minus? Because he's moving down. He's moving down, but with a negative acceleration. That's why it's called deceleration. Okay. So who is moving down with an acceleration of minus 3.9? That means he's slowing down, right? His speed is slowing down until his speed is reduced to V. So that means he comes to a certain point until the speed reduces to V. Okay. So from V1, the speed is decreasing down to V. Okay, his parachute opens, causes him to immediately decelerate at a constant rate of 3.9 for t seconds. By the way, the time taken from this point to this point, from V1 to V is t seconds. Can you see? A diagram like this really helps you to know what's going in each section of your graph. And then what do they say? Until his speed is reduced to V. Okay, his speed reduced to V. Then he moves with his constant speed V. So with his constant speed V, now he is continuing to fall down until he hits the ground. So let's say this is the ground. So now until he hits the ground, he will go at the constant speed V. Which means, do we have an acceleration here? If you're going at constant velocity, acceleration is 0. So in this section, there's 0 acceleration because you go with the velocity V, start and end also at V. Okay. While he is decelerating, okay, they say while he is decelerating, he falls a distance of 73.75. Which section are we talking about? Shall I give these sections name? Starting point A, let's say this is B, this is C, and this is the ground is D. So in which section are we having the deceleration? A to B, B to C, C to D. We have the deceleration in BC. The BC section is the one where we have the deceleration. Is it a negative acceleration? So the A to B we are accelerating, B to C we are decelerating, C to D there is no acceleration. They say while we are decelerating, while he is decelerating, he falls a distance of 73.35. So basically, this section, this BC section is 73.75 meters. Okay. The total time between the instant when he leaves H, okay, leaves H means the helicopter, and the instant when he hits the ground is 20 seconds. Okay. So they've given you this entire time frame. The total time frame is how much? The total time frame is how much? 20 seconds. The total time for the entire journey is 20 seconds. Are you with me? Okay, the total time taken for the entire journey is 20 seconds. Total time. Okay, the parachute is modeled as a particle. Find the speed of the parachute is at the instant when its parachute opens. Where does the parachute open? At which point? At A or at B or at C or at D? The parachute opens at B. This is the place where the parachute opens, right? So you're supposed to find the speed when the parachute opens. How do we find the speed when the parachute opens? What equation do we use? Everything is marked here. What do we use? V equals U plus 80. Let's use V equal U plus 80 downwards. If I want to find the speed when the parachute opens, so I have marked the speed as V1. In my diagram, I marked as V1 equal. Initial is 0. Acceleration 9.8. Time taken is 2.5 seconds. Multiply how much is V1? 9.8 into 2.5. How much? 24.5 meters per second. Agreed? Okay. So in the next part, they say part B, sketch a speed time graph for the motion of the parachutist from the instant when he leaves edge to the instant when he hits the ground. So this is actually by A. This is the place where he leaves the helicopter. Shall I name it as H instead of A? This is the place where he leaves the helicopter and this is the place where he reaches the ground. They want you to sketch a speed time graph for the entire thing. Okay. Sketch a speed time graph for the motion of the parachutist from the instant when he leaves edge to the instant when he hits the ground. Let's do that. Part B. Shall I do part B over here? So let's sketch the speed time graph. So velocity time. So how does it start? It starts at 0, right? It starts at 0 and then how much of a speed? You are accelerating at 9.8 meter per second square for how much? Until you reach 24.5. Let's draw the initial part of the graph. Okay, so you reach like this, something like this. Starting from 0 until where? Until 24.5. Velocity is in meters per second. Okay, so you reach this and then so they have told you this is for how many seconds? You reach the speed in 2.5 seconds. We can mark the time as well, right? The time here 2.5 seconds. Okay, and then what? After that, what happens? The parachute opens, right? The parachute opens and you decelerate. And you decelerate and you come to a speed of V. Okay, so then how do you draw the next part? The decelerating means what? Your graph will, the velocity will drop, isn't it? Your velocity will drop and for time t seconds. Are you going to take it down to the very end here? No, you are reaching the ground at a certain constant speed. So then it's decelerating and then you come to a point like this. You could take it to a point like this. And take this velocity as V. This V, which is definitely a lower speed than this V1. Okay, so you reach this velocity V and then what happens? The remaining part of the journey until you hit the ground, you will travel at the constant speed V. Can you understand? Is this clear? And then when you hit the ground, what's the total time taken when you hit the ground? They have told you the whole journey takes 20 seconds. So this is 20, like the entire journey. And also we had an idea about the time for the decelerating part. They had told you the parachute is decelerating for capital T seconds, right? Yeah, so we could mark that as well here. The parachute decelerating, only the decelerating section has T seconds, just only the decelerating section. Which means how much is this time value? This section is only T seconds. If you want to mark it on the axis, you have to give it the time from the beginning. Only this section is T seconds. So time from beginning should be 2.5 plus T. Isn't it? This value, the full value. And the full thing is 10. So this is your velocity time graph. Make sure the shape is there. Make sure these figures are there. Okay, make sure the shapes and the figures are there. Okay, then we'll move to the next part, part C. Find the value of capital T. Okay, how are we going to find the value of capital T? So to find the value of capital T, if you look at the diagram, okay, we have a piece of information that we need to mark here. They have told you when the parachute is decelerating, it's traveling a distance of 73.75 meters, isn't it? So basically, the decelerating section is this one. This section, the deceleration is given to you actually. The deceleration or the acceleration is minus 3.9, which is the gradient. You do know that the gradient gives the gradient of the velocity time graph is the acceleration. Okay, and then the area under the graph is 73.75, right? Just this section alone, area. Just this section alone. This section alone, the area is 73.75. So we are going to use all those information together to calculate the value of T. Okay, first we'll use the equation. We can find the V in terms of T. Shall we find V in terms of T? So for the decelerating section, for the decelerating part, I'm going to use V equal U plus AT. What's the final velocity? The final velocity we reach in the deceleration section is V, right? You realize I'm talking about this section. The final velocity is V. Starting velocity U is 24.5, right? Acceleration, you know your acceleration is minus 3.9. And time taken is capital T, because they've told you here this section takes capital T seconds. Are you with me? Can I have here the value? V equals 24.5 minus 3.90. Do you agree? Okay, so we'll keep our V here. Now, shall we write the equation for the area? So if you consider the area here, what type of area do we have here? This is the area of what shape? What shape do we have here? This is a trapezium. Half A plus B into H, half into sum of parallel lines into a perpendicular distance between the parallel lines. So let's use the area. Area 73.75 equals half. Who are the two parallel lines? The two parallel lines are the 24.5 and the V. Do you agree? 24.5 and the V are the two parallel lines. Half sum of two parallel lines into perpendicular distance between the parallel lines is how much? What's the perpendicular distance between the parallel lines? It's capital P. So input, take the half here. 73.75 multiplied by 2 equals 24.5 plus what can I do for the V? V is 24.5 minus 3.90 into T. 73.75 times 2 is how much? How much? 147.5. Inside here, 24.5 plus 24.5 is how much? 49 minus 3.90 into T. So do you see that I'm going to create what? It's a quadratic equation. Okay, you can't, you must open the bracket here, right? Because this is not equal to 0. You cannot factorize at this point. You have to open the bracket because to solve a quadratic equation, it must be equal to 0. 49t minus 3.9t square. So take everything to one side. 3.9t square minus 49t plus 147.5 equals 0. Is that correct? So now we can use T equals minus B plus or minus square root B square minus 4AC divide by 2A. How much is T? Calculate, so you have to type it in the cal, or you could give the ABC in the quadratic, but make sure you show your methods. Make sure this is written correctly, okay? If I get here 7.564 and the other answer I directly get 5. Can you see? So for the plus answer, I get 245 over 39. So capital T equals 5. Okay, make sure the method is there so you can write these two answers. 245 over 39 is 295, right? 295 over 39 is 7.56. Okay, and the other one T equals 5. What's the correct answer for T? There are two possibilities, but they do tell you here very clearly what? That T is less than 6. Can you see? They've told you in the question T is less than 6. So thereby what's the T value? T is less than 6. Therefore, your T value should be 5. Your T value should be 5. Do you agree? So this is the answer for part C. Okay, next we'll move on to the last part. Part D. They say find to the nearest meter the height of the point H above the ground. Okay, you need to find this height of this point H above the ground. How the height of the helicopter above the ground. So basically the height of the helicopter above the ground can be found by what? I think you can see from H to B, B to C, C to D, everything is plotted in this graph. All I have to do is what? To find the area under the graph. The area under the graph will give the total distance that the parachutist has traveled. The total distance traveled by the parachutist, in other words, is the distance of the helicopter above the ground. Do you agree with me? The total distance the parachutist falls is the distance that the helicopter is hovering above the ground. So all you have to do in part D is to get the distance. How do you get the distance? So the distance D, you have to calculate the area of each and every section separately. Calculate the area of each and every section separately. Okay, so let's get the area under the graph under each section. So for the first section, the area of the accelerating, that means the part where you are falling freely under gravity, or the part where the acceleration was 9.8 meter per second square. How much of a distance are we falling? It's half into base into height, right? Half into base is 2.5, height is 24.5. Do you agree? The area of the triangle. Plus the next part is the area of the trapezium, which we already know. The area of the trapezium is 73.75. Do you agree? And the next part is the area of this rectangle. How do we get the area of the rectangle? It's length into breadth. The length into breadth. How much is the length here? Now we just found out T is 5. Can I know this value here? 2.5 plus T is how much? 7.5. So 20 minus 7.5 is the length, right? From 20, you should subtract the 7.5 here. 2.5 plus 5, 7.5. 20 minus 7.5 is the length here. And how much is the width of the rectangle? The height of it is V. We found V also. Did we find V? I think we didn't find V, right? We'll have to find the V value. Can you all get me the V value? V is equal to 24.5 minus 3.90, right? This was the equation we generated earlier. Here, V is 24.5 minus 3.9 times T. Can you see? Can you all get me the V value? 24.5 minus 3.9 times T is 5. How much? 5. V is 5 meters per second. Then the area of the rectangle is 20 minus 7.5 into 5, because 20 minus 7.5 is the width and the height is this V, which we found as 5. Do you agree? So now it's a matter of typing everything and getting the answer. Half into 2.5 into 24.5. We'll get that answer first. That's 245 over 8 or 30.625. This is the amount you're falling freely. And then 73.75, and again 20 minus 7.5 is the width of the length of the rectangle. This is 20, and this is 2.5 plus T is the 7.5 seconds. So this width is 20 minus 7.5. And the height is, we found V as 5. We found V as 5, okay? So 20 minus 7.5 into 5 is how much? 20 minus 7.5 into 5, which is 125 over 2 or 62.5. Shall we add everything? So 30.625 plus 73.75 plus 62.5 equals 166.875, right? I think they have told to get the answer to the nearest meter. In the question, what's the answer to the nearest meter? 167 meters. So this is the distance the helicopter is hovering above the ground to the nearest meter. Point to the nearest meter, the height of the point H above the ground. The point H is 167 meters above the ground. Okay, is this clear? Okay, question number 8. Two particles A and B have masses 2 kilograms and 4 kilograms respectively. Then they say here the particles are connected by a light inextensible string. The string passes over a small smooth pulley which is fixed at the top of a rough plane. Okay. So over here we have a rough plane. Okay. I'm just marking it like this. The rough plane, the plane is inclined to the horizontal ground at an angle alpha where tan alpha is 3 over 4. So when they give you tan alpha as 3 over 4, are we going to use tan inverse and get the alpha value? Definitely no. You need to use the triangle, draw the triangle and get sine alpha and cos alpha. Tan alpha is over opposite over adjacent. Right? Tan alpha opposite over adjacent. How much is the hypotenuse? 5. By using Pythagoras theorem. So sine alpha opposite over hypotenuse 3 over 5, cos alpha adjacent over hypotenuse 4 over 5. Okay, then they say the particle A is held at rest on the plane at a distance d meters from the pulley. Okay, so you are keeping the distance d meter from the pulley. The particle B hangs freely at rest. Okay, so this is freely hanging at rest. Vertically below the pulley at a distance h meters above the ground as shown in figure 3. The part of the string between A and the pulley is parallel to the line of greatest slope of the plane. Okay, this is parallel to the plane. The coefficient of friction between A and the plane is 1 over 4. Who is 1 over 4? Mu is 1 over 4. The system is released from rest with the string taut and B descends. Okay, so what are they saying? When they release this, B is descending. So if B is descending down, what does it mean? A will go up, right? If B is descending down with whatever the acceleration B descends down, with the same magnitude of acceleration, A will accelerate up. Okay. And then they say find the tension in the string as B descends. So we are supposed to find the tension in the string as B descends. Just look at how many marks they've given here. They've given you 9 marks for this. Okay, so it's a major question. Mark all the diagrams and there are only 2 equations to use. What is it? There's only 1 equation to use actually. You use F equal MA, but you use it twice. One for A, once for A and once for B. That's it. And then to solve those 2 equations simultaneously to get the tension. Okay. So let's mark all the forces here first of all. What are the forces we have in particle A? Particle A has its weight, which is 2g. Particle A has the normal reaction, isn't it? It's touching the rough flow, thereby it has the normal reaction. And also you realize particle A is attached to the string, therefore what does it have? There's a tension. There's a tension. Okay, it's pulling. Pulling force is tension. Equal opposite tension on the pulley. Okay, right. What else do we have? Particle A is on a rough plane and it's moving upwards. Thereby, who is acting downwards? Friction force will act downwards. Do you agree with me? The friction force or the mu r, because it's moving, you will have the maximum. So shall I mark this as mu r? The mu r force will act downwards. And what else? Now you can see normal reaction is perpendicular to the plane, tension is parallel, friction is parallel. So when you're working on an inclined plane, we prefer to have all our forces either perpendicular to the plane or parallel to the plane. So what do we do here? We can resolve the 2G. Our 2G is not in any of the either of those two directions. When you have someone who is not in either of those two directions, we can resolve. So what happens when you resolve? Do you remember? The alpha comes over here, right? Can you remember? So this is going to be 2G cos alpha, who is perpendicular to the plane. And you will also get over here downwards. You will also have 2G sin alpha, who is parallel to the plane. Do you agree with me? So these are all the forces acting on particle A. So 2G was not helpful in this direction. So I resolved the 2G into perpendicular and parallel. So we are not working with 2G anymore. We are working with 2G cos alpha and 2G sin alpha. Also now all the forces are marked in particle A. Go back to particle B now. Go to particle B. Mark the forces. So what do we have? Equal opposite tension comes from the pulley over here. The same tension. And what else do we have? We have the weight of B, which is 4G. This is it, right? For particle B hanging freely, it doesn't have any other force. There's no normal reaction. There's no friction. Just the tension and the weight. Okay. So that's it. So now we need to apply the equation. Okay. So we'll apply the equation F equal ma. So first, I'll consider particle A. When you consider particle A, you can see particle A perpendicular to the plane. It's in equilibrium. It's not trying to move up or down, right? Perpendicular to the plane. It's in equilibrium. So what happens? R is equal to 2G cos alpha. Do you agree? Normal reaction is equal to G cos alpha. Okay. Then, because we need the normal reaction value to find the mu r for mu r. Okay. Friction value also shall be fine. Friction is mu r. So friction mu is 1 over 4. Normal reaction is 2G cos alpha. Let's find those values. It's easy for us. 1 over 4 into 2G cos alpha is 4 over 5. Can you all simplify and get me the friction in terms of G? Okay, we'll get the answer in terms of G. Okay, 2G, yeah, 2 over 5, 2G over 5. Okay, I'll keep the answer in terms of G, because whenever you use G as 9.8, the final answer should be kept to 2 or 3 as well. So I'll keep G in terms of G here at this point. Okay, and then, okay, I have found the friction, I have found the normal reaction. So now it's time to use what? You know, particle A is accelerating upwards to along the plane. So we will use what now? We will use F equals ma upwards along the plane. So what are the forces acting up along the plane? Tension is acting up. The others are acting down, right? Minus 2G sin alpha minus the mu r, which is the friction. Mu r is the friction, which we found as 2G over 5. So tension minus 2G sin alpha minus mu r equal mass into acceleration. Mass is 2 kilograms into acceleration is A, which is an unknown. Let's simplify this slightly. T minus 2G sin alpha is 3 over 5, right? T minus 4G over 5 minus 2G over 5 equals 2A. How much? What do we get here? T minus 4G minus 2G minus 6G over 5, right? Equals 2A. Do you agree? Then shall we use F equals ma now for particle B? This was to A. So now I will use F equals ma to B. B is traveling which way? B is traveling downwards. So apply F equal ma downwards. What do we get? 4G minus tension equal mass is? What's the mass of B? 4 kilogram, 4A. So that of course comes really easily. There's nothing to think there. So that's equation 2. Now combine the two equations and you're supposed to find the tension. So you have to solve this with P minus 6G over 5 equals 2A. This was the equation 1. And you see, I wrote it over here. So you're supposed to find the tension. Okay, so what do we do here? One easy way to do here is I can say that's minus T and plus T. Okay, one easy thing to do here is you could add the two equations and remove the T. Do you agree? And I can find the acceleration and input the acceleration value back and find the tension. If I add the two equations, can you see the tensions cancel out? 4G minus tension, you are adding with P minus 6G over 5 equals 4A plus 2A. And you need to realize why I'm adding here because minus T plus T will cancel out. Can I know how much is 4G minus 6G over 5? 4A plus 2A, 6A. 4G minus 6G over 5? 14G over 5. So I get acceleration is how much? 14 over 5 times 6 into G. How much is it? How much? 7/15 G is the acceleration. Now input the acceleration. I'll input you equation 1. I'll substitute equation 1. T minus 6G over 5 equals 2A. Shall we substitute T equals 2? A is 7G over 15. Minus 6G over 5 comes here as plus 6G over 5. So simplify, you get T equals 14G over 15 plus 6G over 5. How much is the tension? In terms of G. First in terms of G. Okay, so we found a slight error here, right? Yeah. We have to fix it here. 2G into 3 over 5. Yeah, this is not 4G over 5. 2G into 3 over 5. 2 times 3, that's 6G over 5, right? 6G over 5 minus 2G over 5 is 8G over 5. Is that correct? Now. Yeah, 8G over 5. So basically this equation, the first equation, there's a slight error. So T minus 8G over 5. Okay, so when we add 4G minus T plus T minus 8G over 5 equals 4A plus 2A. Can you all add 4G minus 8G over 5? So basically from here, things are going to change. How much is 4G minus 8G over 5? How much is it? 12G over 5. It's 12G over 5, right? There's a slight change here. So it's 12G over 5 equals 6A, which gives me acceleration is 12G over 5 times 6, which gives me 6G over 5 equals A. Sorry, not 6G, 2G, right? 6 times 1, 6 times 2. 2G over 5 is equal to A, acceleration. Is that okay? Okay, now we'll input the acceleration value here correctly. The acceleration value is wrong. The acceleration value is 2G over 5. So 2 times 2G over 5 is 4G over 5. 4G over 5 plus 6G over 5. Yeah, we are substituting the equation 1, right? The one that I have to correct here. It's not T minus 6G, it's T minus 8G, right? We are substituting the equation 1. T minus 8G over 5 equals 2A. So we will have to fix that. T minus 8G over 5 equals 2A. A is 2G over 5. So I get here tension equals 4G over 5 plus 8G over 5. So tension equal 8G plus 4G is 12 over 5G newtons. So this is the tension value. The exact value is this. If you have they asked the exact or they've just asked you to find the tension. So you could take this, keep this also because for the next part, if you want exact answers, we need to work with 12G over 5. Can I have the 3SF figure? When you input G as 9.8, give your answer to 3SF or 2SF. How much? Exactly. So we get exactly 23.5 to 3SF. 23.52. So, but you have to keep it as 23.5 newtons. Okay. Is that clear? So this is the question for 9 marks. This is what you have to do in part A for 9 marks. Okay. Shall I move to part B? The next part they say on hitting the ground, B immediately comes to rest. So B is traveling h meters, right? H meters, it's traveling under this acceleration 2g over 5 acceleration. It hits the ground. Immediately after, given that A comes to rest, on hitting the ground, B immediately comes to rest. Given that A comes to rest before reaching the pulley. So A is coming to rest before it reaches the pulley. Find in terms of H the range of possible values of D. And you can see they've given you how many marks? 7 marks for this. Okay, so they've given you 7 marks. Okay, first things first. Okay, when you are doing this question, now you can see here, there are things you need to realize. The first thing is, you know that B is going to travel a distance h meters and hit the ground. Okay, and then until it travels this distance h, you realize that you don't have, that there is no issue. Particle B will keep accelerating down, particle A will keep accelerating up in this manner, right? Shall I erase these forces? Okay. Okay, I will erase these forces now. Wait, let me. So I have that. Okay, I will erase the forces because I want to explain to you what's going on here. Okay, so now what happens here is B is going a distance h meters. B will go a distance of h meter and it strikes the ground. So when and while it is traveling this distance h meters, what do you realize? It is going down with that acceleration. What was the acceleration that we found? It was how much? Acceleration value was how much was it? 2 over 5g, right? Can you all check the answer? It was 2 over 5g, right? So it's accelerating down. B started with velocity 0, isn't it? B started off with velocity. Initial velocity was 0. And then it's going to hit the ground. So we say that the velocity with which it hits the ground is V1. The velocity which it hits the ground is V1. Okay. So now simultaneously what happens to A? When B travels a distance h meters, A will also what? Travel a distance h meters on the on this inclined plane, isn't it? So A will travel a distance h meters on the inclined plane. So let's say this is the h meters. Can you see? It's traveling a distance h meters under what? Under that exact same acceleration, isn't it? So under the acceleration, what was it? Under the acceleration, 2g over 5. Are you with me? And then after traveling the distance h meter, what happens? It achieves the speed what? It achieves the speed v1 that I marked here, right? Initial velocity was 0. And after traveling h meter, it also achieves the same speed. Do you agree? Both of them are traveling together on the same string. So they are having the same velocities, the same magnitudes of velocities and same magnitude of acceleration. Okay, and that is until B hits the ground. Now after B hits the ground, they say B doesn't go anywhere, B doesn't move, right? But what happens to particle A? So after B hits the ground, the problem is the motion of A is now what? The motion of A is now going to be independent. What do you mean by independent? Now previously B, it was because of the weight of B, you had this pulling force on A and A was accelerating up, right? But now when B hits the ground, that pull is no longer there. B doesn't pull A anymore. So thereby after this point, A is going to travel independently. Why? The string becomes slack. Why does the string become slack? Because B doesn't pull anymore. The string is completely slack now. Are you with me? This comes in, and at this point, when A comes over here, the string becomes slack. And then the particle A will, what happens now? Will particle A also immediately come to rest at this same point? No, it has achieved a certain speed, right? The speed V1, it has achieved this speed. So with this speed V1, it will what? It will continue to go forward until what? Now, do we have the tension supporting it to accelerate? No, the tension is not there to support it to accelerate. It will keep going forward until what? Until it reaches the speed 0, until it comes to a speed of 0. So until it comes to a point over here, and they say the particle it comes to rest before reaching the pulley. That means it doesn't come and hit the pulley. So it will stop somewhere before reaching the pulley. And at that point, the velocity becomes what? 0. Okay, but the problem is from here to here. So this is the special instance. From here to here, this motion that I marked in yellow color, this happens what? Does it happen under acceleration? No, this happens under a deceleration. There's a deceleration here. And it's a new deceleration. So that needs to be found. Okay, so that needs to be found. Okay, so then they're asking you to find the range of possible values of D, I believe. They're asking you to find the range of possible values of D, right? They're asking you, let me remove this. They're asking you find in terms of which the range of possible values of D. Okay, in terms of which you have to find the range of possible values of D. Okay, so what's the first thing we do here? The first thing you do here is you need to find what? The velocity with which B hits the ground. The V1 speed should be found. Shall we find the speed with which B hits the ground? How do we find that? This is part B, right? How do we find the speed with which B hits the ground? We apply what? V equals, sorry, we'll apply not V equal, we'll apply V square equal U square plus 2A is why? Okay, because we know we need to find the final speed, which is V1. Initial speed of B is 0 plus 2 times what's the acceleration? When B travels the distance h, it travels it under the acceleration of 2g over 5, right? Not 2 over 5, 2g over 5. So acceleration is 2g over 5 into displacement s is h. Do you agree with me? So V1 square is 4gh over 5. Do you agree with me? Which means V1 is root 4gh over 5. Do you agree? V1 is root 4gh over 5. Okay, and then now I found the speed of V1. Now what do we do? Now what do we do? Now the next step you have to do here is in this yellow part, the decelerating part, you have to find the new deceleration. How do we find the new deceleration? You have to find the new deceleration of particle A. So what do? We definitely apply what? What's our equation? X equals ma upwards. So apply F equals ma when you consider this particle at this point. Now the string is loose. So do we have any tension upwards? No. What are the forces we have? Let's mark the forces. We have the friction. Do you agree? We have the friction. What else? We have the 2g sine alpha. Okay, we have the friction. We have the 2g sine alpha, the weight component. What else? Those two, right? Previous diagram also we marked friction 2g sine alpha. In the previous diagram we had tension, but it's not there now. String is slack. Normal reaction 2g cos alpha is not required for, does not make an impact on the forces along the plane. Perpendicular force to the plane do not make an impact on forces parallel to the plane. Okay, so then we can apply F equal ma, right? So F equal ma, both 2g sine alpha and friction acting downwards. Do you agree? So both of them are minus 2g sine alpha minus friction equals mass is 2 kilogram. Acceleration is a new value. Now we have a new acceleration. Minus 2g sine alpha was how much? 3 over 5. And what was the friction value? We found friction previous, right? Friction value was 2g over 5. Do you agree with me? So minus 6g over 5 minus 2g over 5 equals to 2a. So minus 8g over 5 equals 2a, which gives me acceleration when you divide by 2. Minus 4g over 5. Do you agree? The new acceleration is minus 4g over 5. Okay, now what do? We have the new acceleration. The new acceleration, this is the acceleration that you travel this yellow part, the yellow section. So what can we do? Now you want to find the distance d in terms of h, right? Find d in terms of h. To find d in terms of h, basically you have to find the distance that you moved up, right? Shall we find the distance it moved up? How do we find the distance it moved up? Under the new acceleration, we will again use what? V square equal u square plus 2a, because we don't know the time. We need to find the distance that it moved up. We'll use v square equal u square plus 2a. Under the new deceleration, final velocity is 0. Final velocity is 0. Initial velocity is v1 square. Okay, the v1 square. We know the v1 square value, which is what? 4gh over 5. They directly put the v1 square value. Plus 2 into acceleration is minus 4g over 5 because it's a new deceleration, and displacement is x. Do you agree with me? 0 equals 4gh over 5 minus 8gx over 5. Minus 8gx goes as plus 8gx over 5. 4gh over 5. Your task is to make x the subject. 5 will cancel out. G will cancel out. So you get x equals 4 over 8h, or it's half h. Do you agree? Do you agree? So how do you give an inequality for d in terms of h? So now they do tell you very clearly here the particle doesn't go to hit the pulley, right? So if this particle doesn't hit the pulley, what do you have to say about the d distance? The d distance should be what? Now this distance was given to you as h, right? I marked it previously, I erased it. This distance is h, where you moved with the acceleration. This distance is x. D plus the h plus x should be what? Yeah, the h plus x distance should be less than d, right? Because the d should be bigger, because otherwise you definitely need the h distance, and the x distance will go up until it comes to rest. So the h plus x should be less than the d value. Then the particle will not hit the pulley. If it is less, it will hit the pulley. It's not supposed to hit the pulley. So then d should be greater than h plus x is half h. How much is h plus half h? 1h plus half h is how much? 1h, 3 over 2. D greater than 3 over 2h, or d greater than 1.5h. So this is the answer for what? Part B. They asked you to get the distance in terms of d in terms of h, right? Find in terms of h the range of possible. Can you see I got the range of possible values of d? So your d values should be greater than 1.5. The last part, state one physical factor other than air resistance that could be taken into account to make the model described above more realistic. So what could you take something in this model to make this more realistic? What other thing other than air resistance? Okay, other than air resistance, what else could we take? To make it more realistic, what other things could be here? What other factors can like you just need to think something out of the box. You can't say whatever is in the question. Say something that they have not mentioned to make it better, to make it more realistic. What things could you take into account? Don't restate what's given in the question. Okay, do not say R resistance. It's already given in the mention in the question. So it has to be something else, something to make it more realistic. So another force, another external force that we did not consider. So one thing we could consider maybe could be the pulley, maybe the friction. There could be friction at the pulley, right? Okay, yeah. So to make it more realistic, they want you to give something. Want you to give suggestions. Just give a suggestion. So the friction in the pulley, or else you could talk about the string, the weight of the string. Okay, yeah, the length, the whether it's extensible string. Okay, things like that. Just for one mark, give one reason. Just one reason. Okay, so for part D, part C, you could talk about either the friction in the pulley, just one, okay? Or you could say that the string has some kind of a weight. To make it more realistic, just one factor would be more than enough. Or the string is extensible. Okay? Okay, so this is it. This is the end of the, this is the end of our paper.